Okay. Differentials is the concluding lesson of derivatives. Differentials are approximations, aren't exact. We know this. Approximations aren't exact. If we use a tangent line to approximate a curve, it gives us a relatively good estimate. As long as we don't go too far away from the center point. So yesterday, the question is, how far is too far? Considering a function f and label the center point C f of C and draw the tangent line to that point. So you have a curve. Pick a point on that curve and label it C. So here's the center point. We're going to label that point C. That means the height of that point is f of C. Draw in a tangent line to that point. This graph is concave, therefore my tangent line is going to be in. There you go. That's not terrible. What's the equation for the tangent line we just drew in?
F prime. We all try.
Poorly. What would the slope of the tangent line be?
Well, that's what I was going for. I was just going for the other.
You were going for the
I
LX.
had the F of C on the other side.
Okay.
And how do you do it?
If we consider delta x to be to the right of C, so that means we're going to make a new point. We're going to call this new point x plus C. So this distance here represents delta x. Yeah. Well, we're using delta x to describe it, so you could call that delta x if you wanted. What is the y value of this new point on the tangent line? So yes, that means we're going to a point here. Yes. So we're calling that point like, or that distance delta y. How would you find delta y?
What we just did. Wait, no, it's like, I'm wrong.
We find the equation of the tangent line and plug in x plus.
Yeah, so we have the equation of the tangent line. Yep. So you plug in delta x plus c for all your x's.
There's a lot of room on my desk and stuff like
So,
Oh, don't drink that.
This is just enough.
No, it's just that's too. This is not. Wait, this might be vodka. I don't know.
That's better. Jane? No.
That's fine.
You would know like the instinct.
Right away.
That's why I said no.
Yeah, but knowing the kids in your first period, there's a 50-50 chance.
Is that vodka? No.
I'm going to sit there.
I would look at sit. I just see one walking out the room.
Times delta x.
What?
Nothing.
Smart choice, Casey.
Sounds like pasta.
Stop. Miss.
Better not do that tonight.
Wow.
No
one this season has built 3 solid houses, I will say.
What does that mean?
means
Oh! I should have got that.
They're for rent right now.
Hey, I don't
You don't pronounce it.
Okay.
What's wrong?
I don't
That's
care.
why I quit basketball.
You go over there. I remember when you and Jay would use my thing on the boys.
I remember you were freaking
Yeah, on
beasts.
it was, I was on your team, 6th grade.
You were on.
I remember Jimmy's fingernail went through my hand.
So the season cancel out.
I remember one time I thought it was not a lot of time, so I chopped it. She went right into Janice's hand and she put it in her freaking book. I'll never
You shouldn't have told anyone. You should have said it was a pass.
It was not a
She
pass.
threw a dime.
So we get delta y equals f of c plus f prime c times delta x.
Sorry.
So the actual change in delta y is given by that formula there.
I'm just drawing here.
So the y value distance, though, would be in here. So what would the point from here to here be represented by? Like the point on the actual curve to the point on the tangent line curve. Yep, so that's kind of what this is saying. Like, how do you find that? So what would we do to find? So this actual value here, this would be,
Yeah, just subtract the actual from the actual from the x.
You subtract the estimate that we got from that.
so here's the estimate that like we got, and then you would subtract from it this. That would represent, or this, subtract this from that, sorry. Set it backwards to what I was trying to say.
You always subtract the estimate from the original, right?
No. When would you do it the opposite?
When would you?
Well, can't you just do it that way and then?
The
since it's
signs would
negative-
even out
Yeah.
anyways.
When would you have an estimate if you have the exact? Just a real quick.
Will you subtract that whole bottom from that?
What's the
Yeah,
actual?
but you gotta remember, you gotta plug that f of x delta x plus c into the original equation.
I mean, I guess there is a use where you could try to predict if it was in statistics. There's a use for it.
Mm-hmm.
And then, yeah, I don't think you need to do that. For doing calculations on the graph. And you calculate something based on the tangent line,
Ow.
which doesn't really.
Okay. So what we're going to do is use that concept of delta y and delta x and this little concept of the difference here to calculate approximate errors. So the delta x is very small as we get really, really close. We're going to relabel delta x as dx, d for delta, and differential. This is known as the differential of x. We can denote the approximate change in y with dy. So think back to what we know about dy and dx. Now we're talking about delta y, delta x. F prime of x can also be written as dy dx, which is also kind of like saying the differential of y over the differential of x. And now we're going to rearrange these terms again. So the differential of y is equal to the slope in dx.
Well, these integrals make so much more sense by the.
That's why this is the lesson right before integration.
We didn't, I might have not paid attention. We never got that information in physics.
But like if you think about it, this right here, this represents the height,
Yeah.
and this represents the width.
Well, if I knew that was delta x, it makes sense why you subtract the upper end from the lower end, because you're looking for the distance in between.
Find an area between curves.
There's a very real chance I just missed that, but I don't know.
There's also a very real chance you didn't learn it.
I'm gonna look at George, who actually was doing all the integrals.
I don't think
He
anything.
actually
I'm
knows
just
that,
saying that.
the dx and delta x.
Okay, find the differential dy when dx is 0.01. I do like though that you can like see things now, like you understand the connections.
That makes more sense.
Wait, where's example
I was always so confused. Why?
It's probably example 2 on your
It's
paper.
example two on that.
I deleted an example along the way.
Fine.
I want you to find dy. What did we just say dy was?
F prime of x times.
So find f prime of x, so we're going to rearrange the terms to make it a differential. So this is dy dx, the way we know it now. So we're taking the derivative of y with respect to x. Derivative of the x's are, okay. But what we're doing is we're saying, all right, I want the dx, or the differential, to be with my x's. So we're going to multiply both sides by dx. So we have dy equals 5x to the fourth minus 12x squared dx. Because we're not looking for dy dx, we're not looking for the derivative, we're looking for the differential. So I need to isolate my differential dy. And then they tell me dx is 0.001. And x is 2. So what we're going to do is plug in what we know. So dy equals 5, 2 to the fourth, minus 12, 2 squared, times dx, which is 0.01. Yeah, no calculator. So 2 to the fourth is 16. 16 times 5. 2 squared is? 2 squared is? 4 times 12?
32
That's my calculator.
It is your calculator.
80 minus 0.40.
I did the math before the distributing.
You still make it.
Oh, okay. I was looking down to explaining it.
So speaking of explaining, it says on your paper, explain what this means. What does this mean?
The approximate change in y is 0.32.
The approximate change in y is 0.32.
When x equals 2 and dx equals 0.0.
Okay.
Because we said so.
Yes.
Yep.
However, let's instead of saying x equals 2 and dx equals 0.01, what does that really mean? What that means is the change in y is 0.32 when x changes from 2 to 2.01. So what it means is my x value is going from 2 to 2.01. So my y value is increasing, because this is positive, by 0.32.
So I'm like sort of there.
You were, but I just wanted you to understand it goes from 2 to 2.01, not just like repeat the differential aspect.
Now, since the original was a quadratic and we found the line, would that hold consistent throughout? Like for every 0.01, x goes up, y goes up 0.32?
So the original is actually a quintic,
Oh, yeah, I was looking
And we
at
found
that.
a-
I was looking
yeah.
at the wrong graph.
and we found a quartic, but it's only within a relatively small area. So your differential near that will always be the same. What's going to change is the x. So like we could take this same idea and make x 5 and look at 5.01, and then the y value is going to change.
Okay.
So this formula won't change.
Yeah, but
What would change is the y value. So like from 5 to 5.01, y might be decreasing by 0.46. I don't know, I just made all that up. But like the idea is that the y value is going to change depending on where you're on the curve. And that should make sense, because if it's a quintic, we know it could potentially look like that. So sometimes it's going to be positive, sometimes it's 0, sometimes it's negative. So find the differential dy when dx equals negative 0.02. Your x value is high, Now we're talking about sine
Two.
of 3x. So dy, what's the derivative of sine?
Because that's 3x times 2.
Oh wait.
And then what we can do is just start, since we know we're talking about differentials, instead of writing dy dx, you can just put your dx over with the x sides.
Okay.
You could write it dy dx and then multiply it over too. It's your choice.
Sounds good.
So now we want to know what is dy at the instant when x equals pi and dx is negative 0.02. Almost what it represents. So that means we're looking at the cosine of 3 pi times 3 times negative 0.02. So what's the cosine of 3 pi? Negative 1. And 3 times negative 0.02.
Hello.
So what does that mean?
Change in y
is
0.06
when
x changes from
Yeah, I didn't like that the way they just talked like.
pi to
pi negative 0.2.
Yeah. So it's actually going to like 3.12.
I just wrote out the word pi.
Like, because pi is 3.14, it's going to like 3.12. So it's going that way.
We move pi day up by 2 days and then have another pi day.
Pi day is on Tuesday.
No, like-
Pi day is a Tuesday in March.
Hey, wait, I have a
That's what I
question.
Yeah.
How did we work the end of that? Like,
I'm sick of the Maya.
From
So when x changes from pi to pi minus 0.02, which I said is really 3.12.
But should I say pi minus 0.02?
No kidding.
Yeah.
I realized that June 29.
Okay. Find the differential dy when x plus y equals x times y. X equals 2 and dx equals 0.05. Yeah, you do. No. So derivative of x would become, yep, 1. If you want to, you can go back to dx dx. Derivative of y would become 1 dy dx. And then x times y is a product rule. So it's first times root of the second plus second times root of the first. All the dx dx's are 1s. You got to get dy dx's together. So I'll make it 1 minus x dy dx equals y minus 1. Everybody okay so far? So then we want the dx's and the 1 minus x on the same side. So you divide y minus 1 by 1 minus x and then multiply by your dx. But you do. Okay. How could you find y? You have an original and you have an x. So it's like pi plus y. Does yours say pi or 2?
Mine says 2.
Yeah.
Get that trick crap back.
So 2 plus y equals 2y. I'm solving for y.
That's 4. Alright, y equals 2.
Yeah, y equals 2.
Got it. That is smart.
So So that means over here, when I plug into dy, I'm plugging in the point 2, 2. And then my dx is 0.05. So it's 2 minus 1 over 1 minus 2 times 0.05. So 2 minus 1 is 1. 1 minus 2 is negative 1. So negative 1 times 0.05.
We should take a 4-minute break.
I'm just going to give you your homework. We'll do the radius of the circle one tomorrow.
Yeah. That was right before, you hunted me and I think that's
I will.
I haven't counted test next period, so we could focus on off the take that.
I shall not do that.
You say you can hurt it?
Yes.
I'll do it.
Any reason to go, honestly, you can make it wrong.
Teacher abuse.
I wouldn't talk to her, I'm not used to it. Like, I would be picking something wrong here on my face.
It is horrible punishment.
Who? I have to per capita.
Okay.
Alright, I literally just
Alright.
had my pen in my hands and
Alright, so did you forget the
So
right
it's, no, it's 15. I'm going to switch it up a little bit.
I literally just had it in my hand.
Well, I'm taking some away.
Okay, good. They were
It's
adding more.
15 to 18 all. And then 19 to 31. 19 to 31 odds. Yes, I did. I just got rid of 20, 22, 24, 26, and 28. And 30. No, I didn't. It was 15 to 29, 25.
Yeah.
I added 20.